Okay, let's do the notches next up here on the top. It's 1.75, 1 3/4 to center. They're 1 inch deep with a 1/4 inch radius. So if I were going to do this, I would probably just create a position axis on the corner. So I'll go to Essential, no, sorry, I'm going to go to Sketcher and select two edges. Horizontal, vertical is set perfect. So I'll select OK to that, and we'll go normal to screen. Just to make it easy for myself, I'm going to use the slot command under elongated holes here, and I'll just make it, I'll zoom up here so I can see a little bit better. It's 1 3/4 over. I'll come up to about here, come over here, come up to here. And I never like the constraint they give us by default, so I'm just going to delete it. And I will constrain this myself. I'll just try and highlight it and go right to auto constrain and see how it does. A lot of times it doesn't constrain the slot so great. It dimensions to those tangent edges like this. So I really don't like what it does there, but it's not a huge deal. I can just delete this out. Oh shoot, I didn't mean to do that. Delete that number out and then just put in a constraint from that point, which again, something on my selectors, I'm having a real hard time getting the points. I'm trying to go from, I'm just going to go from here to here actually, in dimension to that line. And that is 1.75, which is what the document called out for right here. So 1.75, and then I'm going to delete this constraint, and we'll try and constrain. I'm trying to get that point to this horizontal line, and that's supposed to be 1 inch. Okay, and this really doesn't matter, this length. I mean, if I wanted to, I could make it 1 inch, but it really doesn't matter. In fact, I probably would leave it like this. Now, the reason why I like to create this, I could create a line and trim it, but I want to go past that. Just imagine if you were going to machine this out, you're going to cut through this. It's better to run past the edge than to run right up to the edge. So I'm just going to make a nice full cut. So this seam over here has got a nice cut all the way through that part. So I know visually if I create the line it will look the same, but we've had a number of problems in the past with NC programming and working right to the edges of parts. So I always would go all the way past. A tool cutter would go all the way past, so I try and do the same kind of principle to that. Okay, I'm going to exit out because I got the 1/4 inch radius. I got 1 inch from this edge up and then 1 3/4, so we'll go ahead and exit out. Pop into my ISO view. Zoom down just a bit. And the technique to remove that notch would be the pocket command. So in the model tab, under pad, you'll see pocket. You'll use the pocket command to remove the notch. And I like to just use up to next. So for the type, we're going to change the type to up to next. Select OK. with that pocket highlighted, I'm going to go right to transformation rectangular pattern. Notice that the pocket's highlighted in the specification tree. I want to make sure that's the only thing it's going to pocket. I don't want to pocket the whole solid. So be careful to make sure that only pocket is highlighted in the spec tree. The direction I use is this edge right here. And we'll reverse that direction. Sorry, wrong one. Let's reverse this direction here. And if we go back to the chart, it says the distance will be 2.19. So spacing is 2.1875, not 2.19. Preview that. Select OK. Whoops. We gotta change the first direction. Sorry. Change that back to just one. The direction is going up. We're going to go this direction, the second direction, twice, and spacing 2.1875. Preview that. I have 2, 3, 4, 5 instances. Preview that. 1, 2, 3, 4, 5. Okay. I'll select OK to this. You might be asking, why didn't I use 2.19 right now? Let's open a new website and do a search. Fraction to decimals. Take a look and see if I can find an easy image to read. Okay, that looks good. 2.19 is not a common fraction, or 0.19 is not a common fraction, but 0.1875, I can't do that, so I'll have to leave it here. 0.1875 is 3/16. If you're looking at that on the side on the right, look for the yellow bubble, 3/16. 0.1875 is the actual fraction. Remember, a lot of these ASME and or ANSI drawings were done way back in the day, and we're working to tools that we have. And the most common fraction is 3/16. Okay, so eighths, 32nds, 64ths, but more commonly your eighths, 16ths, quarter inch, half inch fractions is what the shop tries to go by. That's the cutters they use. So I know from experience that back in the day 2.19 really represented 2.1875. 0.1875 is equal to the 3/16 fraction. Your most common fraction, you notice you don't see 0.19. So I can assure you they weren't going for 0.19, they were going for 0.1875. So going back to the drawing, the typical 2.19 in between these notches is 2.1875, or what you would call off 1 3/4, 2 3/16. Down here would be 1 3/8. Over here would be 1 1/8. Those are the fractions, but ANSI ASME specs calls everything out in decimals, so you need to be aware of that. I guarantee you they don't have a 0.38 drill bit to drill these holes out. They're going to use the 3/8 drill bit they have to drill out these holes. Okay, and the 3/8 is a roundup because ANSI specs is 2-place precision is plus or minus 30 thou. If they would have called out 3.875 on a drawing, that means they would have had to work within 5/1000ths of an inch. So way too tight. Okay? Alright, so the best thing to do here now is to go back to your model and verify everything is correct by using your measure command. So we're going to use tools and measure between, and I'm going to select this curve, measure between, and I'm going to select the center. So if you get on the inside, not the top curve, but the inside curvature, the surface of that notch to this face, it gives me a distance of 0.175, which should be the same down here if I built this correctly. Oh no, 1.5 and 1.75. I'll select OK. Let's go back. If this is 1.75 from here to center, and this is 2.19 typical, which is 21875, and this is 12 inches, these numbers gotta be wrong then. 1 inch over here, 1.75. That does seem odd. That seems like this number had to come off somewhere. So let me double check that. I think I did 12 inches. Yeah, so I was 12 inches deep. And my rectangular pattern says I'm going 2.1875, which is your 3/16. Okay, and it's going to show you this anyways. Another thing we could have done was measure item, grab this edge. I got a length of 1.5, and on this one we got a length of 1 1/4, it looks like. Okay, so that would tell me that we're not equally spaced and that this number is not right. Okay, so what I'm going to do here is go to my pattern, and I'm going to solve this by creating a formula for me. So I know that the length is 12 inches, so I'm going to type in 12, and I'm going to hit minus 2 times ED. So 12 represents the length, 2 times ED. ED is the 1.75. That's the distance from the edge to the center of the hole. So ED equals 1.75 because that's what they gave us. So I put 1.75. And I got to divide that by number of holes minus 1. Or in this case, number of slots. So I have 1, 2, 3, 4, 5 slots and 4 spaces in between them. So this would be 5 minus 1. Now I have to take the 12 times the 2 edge distance and sum that. So if you remember in your math, you have to do your summary using parentheses. Again, the 12 is the total length of this prism. The distance from here to here is 1.75, and I need that on the other end, so from here to here should be 1.75. So I'm taking the total sum of this, minusing this where it's going to start, minusing this other end where it's going to end. That gives me my length from the first slot to where the last slot should go. And then I got to tell it how many spaces I have between each slot. I have 1, 2, 3, 4 spaces. So that's total number of slots. You get 5, and that has to be summed up. So I put parentheses around that and a close parenthesis around the 1, and I'll hit preview, and it's 2 1/8 is what that number should be. Select OK. I didn't see that move. It doesn't look like it even moved. Oh, wait a minute. That's what it, yeah. What they're saying was it was 2 3/16. But why didn't my part update? Oh, I put that formula in the wrong one. It was supposed to be in the second one. So right here is 2 1/8. I know it's 2 1/8, so I can do 2 plus 1 divided by 8, which is going to be the 2 1/8. I'll hit tab. That's 2 1/8. You can see that it shifted. I'll select OK. And the true distance between the notches to maintain 175 on both sides, keeping these lengths at 1.5, would be a distance of 2 1/8. And I'll just verify that by going from slot to slot. And that minimum distance is 2 1/8. Okay, so obviously the drawing must be wrong, because we can see from here with the length being 12 and these being 1 3/4, which is what they're calling off on the part here, 1 3/4. To have it 1 3/4 on both edges, the distance typical would not be 2 3/16. It would be 2 1/8, which would be 2.125. Alright, that concludes this demo on how to insert the notches. I'll do the holes on the top next, or no, the slots on the top next. We'll use the same thing. We'll create a slot and do a rectangular pattern if you want to try that out before you watch my demo.